In 10 through 15, we were told to tell the type of sequence, the common ratio or difference, the next three terms, and the rule. So in number 10, 1 to 5, I could add 4, and yes, so this is an arithmetic sequence because I'm adding 4. You don't have to put the plus there. It is a common difference. It's assumed to be positive. So the next three terms plus 4 would be 17, plus 4 would be 21, and then plus 4 would be 25. Your rule is start with 1 and add 4 repeatedly, or add 4 repeatedly starting at 1. On this one, 60 to 30, 30 to 15. Okay, I can see if I take 30 over negative 60, I get 1/2. If I take negative 15 over negative 30, I also get 1/2. And yes, it works for this as well. Negative 15 over 2 divided by 15, negative 15, that would be the same as negative 15 over 2 times negative 1 over 15, or 1 over negative 15. Those would cancel, and I would get 1/2 again. So this is a geometric sequence with a common ratio of 1/2. So these two are the same thing. It's not two different terms. So as a fraction, it makes it pretty easy to do it. So negative 15 over 2 times 1/2 is going to become negative 15 over 4. Then we're going to have negative 15 over 8 and negative 15 over 16. Multiplying by 1/2 each time. The rule is start at negative 60 and multiply by 2, by 1/2 repeatedly. On this one, I can see they're adding 7. 100 plus 7 is 107. 107 plus 7 is 14. So this is arithmetic. The common difference is 7. The next three terms would be 128. 128 plus 7 is 135. And 135 plus 7 is 142. So we start at 100 and add 7 repeatedly. On this one, we are subtracting 5. So it's an arithmetic sequence with a common difference of negative 5. So negative 15 minus 5 would be negative 20, then negative 25, and negative 30. And the rule is start at 0 and add negative 5 repeatedly. Notice I'm still using add and just indicating that I'm adding a negative number, keeping that definition of an arithmetic sequence. Okay, to get from 26 to 15, I would subtract 11. And that will work again from 15 to 4. Subtract 11. And 4 minus 11, change your sign and add. The signs are opposite, so we subtract and find the sign of the larger. So this is an arithmetic sequence, a common difference of minus 7. So negative 7, no, not negative 7, negative 11. Sorry about that. So negative 7 minus 11, change my signs and add, is going to become negative 18. Negative 18 minus 11 is going to be negative 29. Negative 29 minus 11 is going to be negative 40. And your rule is start at 26 and add negative 11 repeatedly. And the reason why we're saying add negative 11 is because of the definition of an arithmetic sequence. An arithmetic sequence is a sequence in which we add a common difference. On this one, 1/10, 1/2, 5 halves, 5 halves. It's probably easier to see from here to here and here to here. If I take 1/2 and multiply it by 5, I get 5 halves. And then if I multiply that by 5, I get 25 halves. And the same thing happens from 1/10. 1/10 times 5 would be 1/2. So my common ratio for this geometric sequence is 5. And it is a geometric sequence common ratio there. And so I'm going to multiply by 5. So 25 over 2 will become 125 over 2. 125 times 2 is 625, or not times 2, times 5. And then 625 times 5, 25, carry the 2, 10, 12, carry the 1, 30 plus 1 is 31, 3,125 over 2. Your rule is start at 1/10 and multiply by 5 repeatedly. Okay, in this one, 16 through 21, they want me to tell what kind of sequence it is. So to check for arithmetic, take one term and subtract the term before it and see if you get the same thing. I'm taking each term and subtracting the term before it. I got the same thing. It's an arithmetic sequence with a common difference of 4. Doing the same thing on number 17, -4 minus the term before it, which is -8, that would become 4. -2 minus -4 would become 2. So it's not arithmetic. So to check for geometric, take the term before and divide it by, or take the term and divide it by the term before. I get 1/2. -2 over -4 is 1/2. -1 over -2 is 1/2. So this is a geometric sequence with a common difference or common ratio of 1/2. Here, 4 minus 3 is 1, 5 minus 4 is 1, 6 minus 5 is 1. This is an arithmetic sequence with a common difference of 1. 22 to 11, I would have to divide it by 2 or multiply by 1/2. That won't get me from 11 to 0. So let's check arithmetic. 11 minus -22. Change my signs and add, that's 11. 0 minus -11. Change my sign and add is 11. 11 minus 0 is 11. This is an arithmetic sequence. 10 to 1, I would either have to subtract 9 or multiply by 1/10. It will not work to get from 1 to 20. This is neither. Here, pretty sure this is geometric, but let's check. One term divided by the term before it. So 1 over 100 times 200 over 1. The zeros would drop. 100 will go into 200 2 times. 1/50th divided by 1 over 100. Invert and multiply. 50 will go into 100 2 times. So yes, this is a geometric sequence with a common ratio of 2. Moving on to the next page, we're going to take our x and replace it with -2. -2 squared is 4. 4 times 1/2 is 2. So we put in a -2 and we got out a +2. Put in -1. -1 squared is 1. Times 1/2 is 1/2. So we put in a -1 and we got out 1/2. Put in 0. 0 squared is 0. Times 1/2 would be 0. Put in 1. 1 squared is 1. 1/2 times 1 is 1/2. And then put in 2. 2 squared is 4. Half of 4 is 2. So we put in 2 and got out 2. So we have negative 2, 2, negative 1, 1/2, 0, 0, 1, 1/2, and 2, 4. This is a quadratic, so it should be U-shaped. Because of that 1/2 in the front, it's a fatter U. And then 2 to the absolute value of x, so we have 2 times the absolute value of 2. The absolute value of 2 is 2, so we're going to get 4. 2 times the absolute value of negative 1. Absolute value of negative 1 is 1. We get 2. Put in negative 1. Got out 2. Put in 0. Absolute value of 0 is 0. 2 times 0 is 0. Put in 1. Absolute value of 1 is 1. 1 times 2 is 2. Put in 1, got out 2. And then finally put in 2. Absolute value of 2 is 2. Times 2 is 4. So we put in 2 and got out 4. This is an absolute value function. It should be pointy. It should be a V. So negative 2, 4. Negative 1, 2, 0, 0, 1, 2, and 2, 4. I don't have a way to use a ruler here, but this is what it should look like. It is a V, and it's a tighter V because of that 2 in front of the absolute value. Okay, here, absolute value of negative 2 plus 1. The absolute value of negative 2 is 2 plus 1 is 3. So we put in negative 2 and we got out 3. Put in negative 1. Absolute value of 1 is 1, plus 1 is 2. Put in 0. Absolute value of 0 is 0, plus 1 is 1. Put in 1. Absolute value of 1 is 1, plus 1 is 2. And then finally put in 2. Absolute value of 2 is 2, plus 1 is 3. So because of that plus 1 on the outside, what has happened is our absolute value has jumped up. It has been translated up 1. And there is no 2 in the front of the absolute value, so our V is a little wider here than it was on the last one. And then moving on to the next one, we have the square root of x squared, or x squared plus 5. So negative 2 squared plus 5 is 2 squared is 4 plus 5 is 9. Negative 1 squared plus 5. Negative 1 squared is 1 plus 5 is 6. 0 squared plus 5. 0 squared is 0 plus 5 would be 5. 1 squared is 1 plus 5 is 6. And 2 squared is 4. 4 plus 5 is 9. So again, with that plus 5 on the outside, we have shifted things up. 1, negative 1, 6, 0, 5, 1, 6. And so it is a U-shaped graph that's up there bottoming out at 0, 5. And then we have some exponential functions, and I think I have an issue here, so let me check. Okay, my problem numbers were wrong and I wanted to switch which ones I did. So on this one I have 1/4 to the x power, and this will be fixed before I give it to you. So we have 1/4 to the 0 power. Anything to the 0 power is 1. So we put in 0 and we got out 1. 1/4 to the first power is 1/4. So we put in 1 and we get 1/4. 1/4 squared is 1/4 times 1/4, which is 1/16. And then 1/4 cubed is 1/4 times 1/4 times 1/4, which would be 1/64. So on this, 1, 2, 3, 4, 5, 6, 7, 8, I'm going to go up 8 and call that a half. 9, 10, 11, 12, 13, 14, 15, 16. And when I get up to 16, that's going to be 1. So when I go to graph this, and why did I go by 8s? Because these 4, 16, and 64 are easy to connect with 8. So I have 0, 1, 1 and 1/4, which would be right here. No, I think I have that in the wrong spot. I needed to, did I go up 8? 1, 2, 3, 4, 5, 6, 7, 8. I did. 1, 2, 3, 4. 4 up, because that would be halfway between 0 and a half. And then halfway again, and halfway again. And so this is what our graph is going to look like. And I missed that dot there. Let's try that again. And remember, it's going to follow that x-axis and not actually cross it. And the reason why it's exponential decay is because the thing that has the x on it, the exponent, is a fraction less than 1. And then this is 3 to the x, not 3 times x. So 3 to the 0 power is 1. So we put in 0 and we get 1. 3 to the first power is 3. Put in 1 and get 3. 3 squared. That's 2 cubed. 3 squared is 9. So we put in 2 and got 9. 3 cubed, 3 times 3 is 9, times 3 is 27. And we'll get rid of that one. So we put in 3 and we got 27. So if we scale this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Let's not bother scaling it. 0, 1, 1, 3, 2, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then 27 would be like somewhere out here. Up there. So I just went by ones, and since I went by ones, I don't have to label the axes. And then here, tell what it is. This is a monomial. Here's my minus sign here, and there's something on either side, so that's a bi. This is a monomial. Some addition, subtraction signs, and there's 3 terms, so that's tri. Monomial, monomial, binomial, again, addition, subtraction, and a term on either side. Same thing happens in 42 and 43, and 44 is a trinomial. And then here, evaluating, so this would be 2 to the 5th. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. This would be -3 squared minus 2. That's 9 minus 2, because -3 squared is a positive 9, and I get 7. 2 squared minus -3 minus 1. 2 squared is 4. Change my sign and add, and I get 6. And make sure you show your work on these. So this would be 2 times -3 times 2. 2 times -3 is -6, times 2 would be -12. 3 minus -3 times 2. 3 minus -3 times 2 is -6. So then we would change our sign and add and get 9. On these, since it's a plus sign, we can just take them out of the parentheses, because that would be the equivalent of a +1 multiplying by that second parentheses, which isn't going to change anything. And then I'm going to combine like terms. I have 3a squared. A and A, I have 2 a's. And then 1 and 7, I have 8. So m squared minus 5m minus 2. Again, that's a plus sign, so it's just +1. times those things, which is just going to be those things. M squared and 3m, and 3m squared is 4m squared. Minus 5 plus 3 is minus 2m. Negative 2 and negative 10, signs are the same, add them and keep the sign, so it's negative 12. 3x squared minus 4 minus plus x squared minus 2x plus 6. So putting my x squareds together, I have 4x squared. I don't have any other 2x's other than the minus 2x. And then negative 4, positive 6 is positive 2. The signs are different, so we subtract and keep the sign of the larger. Here on this one, that's a negative 1, so it's going to change the signs of all of those when I multiply through. It didn't change signs in the previous problems because it was a plus sign in between there. So 7p minus 3p is 4p. Minus 5q minus 2q, they're both negative, so I add them and keep the sign. And then plus 2 and minus 4, the signs are different, subtract and keep the sign of the larger. 10w squared plus 6w, carrying that negative 1 through, is going to give me negative 7w squared plus 3w minus 5. So 10w squared minus 7w squared leaves me with 3 squared w's. 6w plus 3w, that's 9w's. And then there is only that negative 5. Carrying that negative 1 through, changes those signs. So 9x minus 3x is 6x. Negative 3 plus 9, signs are different. Subtract and keep the sign of the larger, so we get 6 again. Multiplying polynomials, a times 2a is 2a squared, and a times 5 is 5a. 4c times c, 4 times 3 is 12, c times c is c squared. And then 4c times negative 7 is negative 28c. Negative 6y times 5y is negative 30y squared. Negative 6y times 3 is negative 18y. 3x times x is 3x cubed. 3x times negative x is negative 3x squared. And then 3x times negative 5 is negative 15x. And you could have written those out underneath like this. I can do them in my head. X times x squared is x cubed. X squared times 7 is 7x squared. And it's positive because that's positive. That's going to be 2x to the 4th. 2x squared times the negative 3x is negative 6, and my x is cubed. And then negative 12x squared. And then the last ones you FOIL. First, outer, inner, last. And then combine like terms, we would get x squared plus 7x plus 12. Again, first, then outer, then inner, then last. And combine your like terms of negative 5x and a positive x. The signs are different, so I'm going to find the difference and keep the sign of the larger, so I'm going to have negative 4x. X squared first, then outer, negative 4 times x, then inner, negative 2 times x, and then last, negative 2 times negative 4. We get a positive 8 here. It is positive because negative times a negative is positive. And then lastly, you need to combine your negative 2x and your negative 4x to get you your negative 6x here in the middle. So you end up with x squared minus 6x plus 8. Don't forget to go over your flashcards for this chapter as well.